Question 12b. A Ferris wheel has a radius of 20 meters and is rotating at a rate of 1.5 radians per minute. The top of a carriage is h meters above the horizontal diameter of the Ferris wheel. The angle of elevation of the top of the carriage from the center of the Ferris wheel is theta. Part 1. Show that dh d theta equals 20 times cos theta. Using right-angled trigonometry, sine theta is equal to the opposite side over the hypotenuse, so sine theta equals h over 20. Rearranging this equation to make h the subject, we have h equals 20 times sine theta. Differentiating h with respect to theta, we get dh d theta equals 20 times cos theta as required. Part 2. At what speed is the top of the carriage rising when it is 15 meters higher than the horizontal diameter of the Ferris wheel? Give your answer correct to one decimal place. This is an application of related rates of change and the chain rule. Now dh dt represents the speed of the carriage with respect to time, and by the chain rule, dh dt is equal to dh d theta times d theta dt. And it's given that d theta dt is equal to 1.5 radians per minute. Now when h equals 15, 15 equals 20 times sine theta from part 1. Rearranging this equation to make theta the subject, we get sine theta equals 3 over 4. Hence, theta equals inverse sine of 3 over 4. So in other words, when the carriage is 15 meters above the horizontal diameter, the angle that it forms with the horizontal diameter is inverse sine 3 over 4. Hence, dh d theta equals 20 cos inverse sine of 3 over 4. So I've left the angle in exact form for the time being. Now dh dt is equal to dh d theta, so that's 20 times cos of inverse sine of 3 over 4, now that we have a value for theta, multiplied by d theta dt, which is 1.5, and that equals 19.843 and so on, which rounds to 19.8 meters per minute, correct to one decimal place. Scan the QR code to access the HSC revision video catalogue.